the physical book person, I just type in the page number. Oh wait.
I'm just going to explain the idea behind what we are going to do next. We won't try anything until tomorrow, so don't worry too much. And please try to be awake tomorrow.
Bring coffee. Bring coffee.
I bring coffee to class.
Oh, yeah.
I already had coffee. It's not working.
I didn't drink coffee today. It's like killing me.
Okay, I can't seem to find that. Turn off the projector, I'll show you something. Let me see.
I need to get a coffee mug.
You even need the
Okay, so this is what we shut. Uh-oh, I already asked you to turn it off. Okay, never mind. From tomorrow now, because it's like 5 or 3 minutes to 1 o'clock, we'll be looking at something called proof by induction. And we'll be going through about 3 steps of it. So in proof by induction, you could have something like show that maybe 2 to the power n plus 7 to the power n plus 5 to the power n is divisible by 13. I'm not sure that statement is right, but I'm just giving you some idea. Show that this is divisible by 13. Or you could be asked to prove that maybe 1 plus 2 to the power n, or no, a plus b to the power n is always greater than ab. Now, of course, you don't know what a and b are. In this case also, n could be anything. So in proof by induction, we start by assuming, what is it called now? We assume the first, maybe when in the case of 1, you know this is like a general n. Can I have some silencer? General n, you assume the case of 1, test it if it is valid. Of course, you don't have to test the case of 2. So, but of course you can test the case of 2. If that is valid also, then we assume a step. This is the process now. You check the first and maybe the second, then you assume for a step k, for example. Now k could be anything, right? You have established 1 and 2. Then you assume k is true, which means when n is equal to k, the answer is right. The idea is this. I know it is right here because I know what that step is. I know it is right here because I know what that step is. Then I pick any random step here. And if I can show that the next step is also true, because this step is any random step called k, and I can show k plus 1 is true, then I've showed everything. Because by this proof, it means if I know that k plus 1 is true, then I can prove that k plus 2 is true. Do you understand? I assume k and I show k plus 1. What does this mean? It means when you assume a previous step, the next step is always going to be true. Assuming the previous step means acknowledging that it is true. Then use that to show that the next one is true. It's the same as acknowledging that this is true, which in turn will mean that k plus 2 is true. Which also means that because this is true, what happens? K plus 3 situation will be true. And if this one is true, what happens? K plus 4 situation will be true. That is why we say it is now true for all n. Do you understand that? So this is the process of induction. Remember our AP formula, 1 plus 2 plus 3. Who can remind me what the summary of this is? N plus 1 divided by 2, right? So this we can prove by induction. Because we are not sure if at point R this formula will hold. But a proof will, if you can prove in general, a proof will establish that for you. So we look at that from tomorrow. We pick them different categories of question under induction. And after induction, we go to other proofs. Alright? My goal is, before we go on Thursday, we have at least 2 of those proofs done before we go for Christmas. We'll send you the video. Because we have double lesson, I want us to take it seriously. Okay?